Hello, in today's video I will show you how to write and name binary ionic formulas and binary molecular formulas. First off, let's do binary ionic formulas. This is always between a metal and a nonmetal, and there are a few rules. Rule number 1, the cation goes before the anion. A cation is an element with a plus charge, and anion is an element with a negative charge. Second rule, the anion always ends in IDE unless you're using a polyatomic ion, then it ends in the ion's ending. Second, if you're using transition metal, when writing the name of the transition metal, you must also write the charge in numeral form. Okay, first off, let's do them with just representative elements. Here we have calcium phosphide, C ends in IDE. So the first step to make it into a formula is writing down the symbols for each thing. Calcium is Ca, phosphorus is P. Next step is writing down the charges. Calcium has a 2 plus charge. Phosphorus has a 3 minus charge. Now we're going to use the cross step to write the formula. We take the cation, put down its symbol, and then we take the charge of the anion. Remove the charge, but still write down the symbol. Then we take the anion, write down the symbol. Then we take charge of the cation, remove the charge, and write down the symbol. So here we have Ca, 2, P, Ca3, P2. Now I will show you how to name a formula. Here we have the formula Li2Se. When writing the formula name with just representative elements, you do not need to worry about the charge. You take the first symbol, write its name. In this case it is lithium. You take the second symbol, write down its name, but with IDE. So in this case, it is selenide. Now we will use it with polyatomic ions. A polyatomic ion is just an ion with more than one atom. And another rule is, when using a polyatomic ion, if the charge is more than 1, you must have a parentheses. Okay. Here we have NH4. N. The first one, the cation, is the polyatomic ion. So we must write the polyatomic ion, which is ammonium. The second one is nitrogen, but in this case it is nitride. There you go. Now we will take a name and turn it into a formula. Here we have calcium, acetate. We write down the symbols. Calcium, it is Ca. For acetate, it is CH. 3 COO. The charge for calcium is +2. For acetate, it is -2. And because one is a +2 and one is a -2, they cancel out in the formula. So when you write it, instead of writing Ca2 CH3 COO2, you just write Ca CH3 COO. Okay, now I will show you how to use this with transition metals. Here we have Pb, Cl4, and Fe, S. For the first one, our metal is lead, so lead. And then its charge is +4, so we must write the 4 in Roman numerals. And then we have chlorine, which turns to chloride. Now here, this is iron. Two. Sulfide. Now if you look at the first problem, we see that the chlorine has a 4, and the name, it has a 4. But over here, the sulfur doesn't have anything, yet the iron is 2. This is because this is a charge, and so sulfur, even though it doesn't have anything, it still has a charge of 2 negative. So our iron must balance it out. Instead of having more than one iron, it gets a charge of 2 plus, balancing out the equation. So the charge is 2 plus, and you write it in the name. Now let's take a name and turn it into an equation. Here we have iron, two, sulfate, as you can see, it doesn't end in IDE, it ends in ATE. This is because sulfate is a polyatomic ion. So when writing this out, we must take the symbols. Iron is Fe, sulfate is SO4, iron has a charge, in this case of 2, because it comes first, it is +2. SO4 then must have a charge of 2 minus, because they are both 2. When we write them out into the equation, we do not write 2. We just end up with FeSO4. Okay. Now next we will learn how to write and name binary molecular formulas, or also known as binary covalent formulas. There are, of course, a few rules to go along with this. Rule 1 is you have to know the prefixes for the formulas of 1 through 10. Rule 2 is when the cation only has 1, you do not write the prefix of mono. And rule 3 is if the element begins with a vowel, you get rid of the O in mono, which is 1, and A in the other prefixes. Okay, let's start off with a simple one. We have CO, which is carbon, monoxide. As you can see here, we did not write mono carbon because it's a cation, and we did not write mono oxide because oxygen begins with a vowel. Okay, let's do another one. We have IF4. This is iodine. Fluorine, but because there's a 4, we must write the prefix of tetra, which is 4. And of course it ends in IDE, so tetrafluoride. Next, let's take a name and turn it into the formula. Here we have tetra. Tetraphosphorus. Dec. Oxide. If you notice here, we wrote dec instead of deca because oxide begins with an O, which is a vowel. So we take the symbol, which is phosphorus is P. Then we write the prefix, which is 4. Then we write O for oxide. And we write the prefix, which is deca, so it becomes 10. There you go. I hope this video was useful, and I hope to see you again.